Yesterday we have started about the relationship between the current and the charge of the charge. So today we'll see some example of how to calculate, how to determine the charge or the current. We know the relationship. We know that ET equal derivative of the charge with respect of time. So if I have this one, sometime I can determine the charge Q. Q is the integration of the currents with respect of time. So today we'll see some example how to determine the currents and the charge. How to determine the current and the charge. In this example, they tell us to determine the current and to sketch it. We want to determine the current and to sketch the currents. We know he already give us the charge. Qt is given. So we want to determine the currents. First, when we determine the charge, we'll derivative to get the currents. Let's see. In this curve, we have the curve of the charge. But if we realize that the curve is not the same from all time, so we will determine the charge from 0 to 1 second, from 0 to 1 second, as we see yesterday. From 0 to 1, we have the curve of the charge is 1. We have Q equal 1. So when we see yesterday, like the previous video, we see that if the charge is constant, the current will be 0. Why? Because when we want to derivative of constant 1 is going to be 0. It's going to be 0. So the current will be 0 when the charge is constant. Now from 1 to 2, from t is 1 up to 2 seconds. So we are going to determine what is the charge from the 1 to 2 seconds to 2 milliseconds. We have to determine. We see the previous video that if we have this one, the straight line, it's going to be Q t equal mt plus b, the general equation. Now let's determine the value of m and the value of b. To determine the value of m, we'll see what's the point. If we take this point, from this point, what's the value of q? We have 1 minus, what's the second point? The second point I have what? I have 3 minus 3. Now from the first point that I take, I have 1. What was the time? The time was 1. So what from 2? What was the point? The time is 2. So I have 2. In this case, if I calculate, I will get the value equal 2. It's the same case. Another person, I can also take the last point, which is 3, minus this point, it is 1. But I have to respect, when I take the point of I start with the point of 3, I will take its time, corresponding time, which the corresponding time, it is 2. Minus the time of 1, the time of q equal 1, the time was 1. So I have to start also to come to 1, so that I can determine the value of it will be 2. Same point. So I already calculate the value of m. I can determine the value of b, in that I have qt equal 2t, because the value of m is 2, plus b. Now let's determine the value of b. To determine the value of b, I take initial point. I can take at t equal 1, the value of q, it is 1. So I'll have the value of q, it is 1, when t equal 1. So when t equal 1, the value of q is 1. I have 2 multiplied by 1, plus b, which will give me b equal 1 minus 2 equal minus 1. Now I have the value of q, qt equal, I have the value of q, which is giving me qt equal 2t minus 1, because the value of m, it is 2, and the value of b, it is minus 1. So to determine the currents, I know the formula, just apply. What's the formula? I have to derivative with respect of time, derivative of q, my q, it is 2t minus 1, which is going to give me equal 2. So from 1 to 2, the value of it is 2. Now I have to determine from 2 to 3. From 2, time is to 3 seconds. What is the value of q? The value of q from 2 to 3 is constant. It's constant. It's constant. When the value q, it is constant, when it is constant, I can determine the current. It is constant. So the value, I know directly that the value of current is going to be 0, because I know that when the charge is constant, the derivative of constant is directly equal 0. Now I have to determine the value of q from 3 to 4. But if we look at it, from 4 to 5 is the same straight line. So I don't need to find the charge from 3 to 4. I can directly go to from the time from 3 to 5. From 3 to 5. Now, from 3 to 5. From 3 to 5, when I have now I'm going to determine from 3 to 5. Now, from 3, when t is less than 5, the value of qt is going to be, to determine the value of q, let me put the graph. I have to see from 3 to 5. We already say that we don't need to find the charge from 3 to 4, because from 3 to 4 is the same straight line from 4 to 5. I can directly go from 3 to 5. No, from 3 to 5 it's a straight line. We know directly mt plus b. Let's find the value of m. I start from 3, I have 3. From 5, I have what? From 5, I have minus 2. So it's going to be 3 minus 2. So what was the time from 3? The time, it was 3. What's the time? It was 5. Now finally I'm going to go 3 plus 5. 3 plus 2 is going to be 5. 3 minus 2 is going to be, finally is going to be minus 5 by 2, which is minus 2.5. Now I have qt equal minus 2.5 t plus b. Let me determine the value of b. I choose one point. When t equal 3, the value of q is going to be 3. So it's going to be minus 2.5 multiplied by 3, because the time I choose at point 3, the time is 3, so the value of q is going to be also 3 plus b, which will give me the value of b is going to give me, I have to calculate minus 2.5 multiplied by 3 is going to give me minus 7.5. If I minus 7.5 here is going to be minus 7.5, I have to come here, is going to be plus. So B is going to be the 3 plus, this one is giving minus 7.5. I take this minus 7.5, I come here, it's going to change the sign, plus 3.75, which is giving me the value of 10.5. So I have the value of B. Now my charge is going to be 50 equal the value of M. The value of M I already calculated, minus 2.5 T plus 10.5. Now if I have the value of the charge, I can determine the current. We saw the previous slide. We see that the charge, the current is going to be the derivative with respect time of the charge, minus 2.5 T plus 10.5. So this one is going to give me minus 2.5. That's the value of the charge. Now if the value of the current, now if I come from 5 to 6, when time is starting from 5 to 6, the value of the charge is what? Is constant. Qt is constant. So Qt is constant. Qt is constant, which is equal minus 2. And we saw the previous one. When the charge is constant, derivative of constant is 0. So the current is going to give me 0. Now I have to go from 6 to 7, or 7 to 8, and 8 to 9. From 6 to 7, the same straight line as 7 to 8 at 8 to 9. So I don't need to go from 6 to 7 and 7 to 8 and 8 to 9, because all they have the same straight line. I can go directly from 6 to 9. Now when the time is from 6 to 9, the charge Qt is equal minus B. Minus B is going to be M, as we see the previous one, empty plus B. Now to find the value of M, I can go now directly, which is going to give me the value of M. Is going to give me, I can take this point. This point I have minus 2, minus the second point I have minus 2. Now at minus 2, what was the time? The time was what? It was 6. Now the time, these two, the time is what? The time is 9, which is going to give me the value of M. Minus 2 is going to be minus 4. Minus 6 minus 10 is going to be 4 by 3. Now I have Qt. The value of Qt I have the value of Qt. In this case, it will be minus 4 by, is going to be 4 by 3. The value of is going to 4 by 3 T plus B. Now we realize when we did not find the value of B, but when we go to derivative, is the B is be cancelled because it is constant in the derivation. So I don't need now to find the value of B. I hope you can calculate by yourself. The value of the charge is going to be the derivative of this one. The derivative of this one, which is going to be derivative of this one for 3T plus B. B is constant. It will give me directly 4 by 3, which is equal 4 by 3, which is equal 1.33, which is equal 1.33. Now I already found the currents. Now from 9 to 10, from 9 to 10, when the time is between 9 t and 10, and 10, it is constant because the values give me 2. The charge is constant. When the charge is constant, we already see directly constant, which is equal to the constant equal to, so the current, it will be 0 because the derivative of constant is going to be equal 0. So the current in this case is equal 0. Now I already found the current from the previous times. Now I'm going to sketch the currents. To sketch the currents, now I'm going to state the currents. To state the currents, I will start plotting each current from each time. I have 0 from 0 to 2, from 2 to 3, 3 to 4, 5, 6, 7, 8, 9, 10. If I come back at the previous one, I want to see the value of the current from the current from 0 to 2, what was from 0 to 1, it was 0, and from 1 to 2, from 1 to 2, it was 2, and 2 to 3 it was 0. From 0 to 1, I have 0. From 1 to 2, I have 2, and from 2 to 3, I have 0. So from 0 to 1, from 0 to 1, I have 0. From 1 to 2, I have 2. From 2 to 3, I have also 0. So it's going to be like this one, because from 0 and come here, 2 to 3. Now from 3 to 4, I have to see. Now from 3 to 4, from 3 to 4, what was the value? From 3 to 4, if we see, from 3 to 4 and 3 to 5, it was all same. So from 3 to 5 is going to, it is minus 2.5, and from 5 to 6 it was 0. 5 to 6 it was 0, and the 6 to 9 it was, from 6 to 9, from 5 to 6 it was 0. Now I have minus 2.5, minus 2.5 from 3 to 5, and I also have 0 from 5 to 6, and I also have 1.3 from 6 to 9, and from 9 I have 0. So mean that if I come back in my graph, I will get that it's going to be minus 2.5 from 3 to 5, which is minus 2.5. The graph is going to be minus 2.5. Now it's going to be 0 from 5 to 6. 5 to 6 is going to be 0. Now from 6 to 9 is going to be 1.3. 1.3 is here from 6 to 9, and from 9 to 10 is going to be 0. So this is the sketch of our currents. That is an example of how, if you give me the curve of the chart, he told me to determine the currents and to sketch the currents that I already determined. Next video we'll discuss about the voltage, the relation between the voltage and the energy.